Here is the great challenge of the multiverse: evidence. Science thrives on predictions you can test, measure, and, if wrong, discard. But how do you test a universe you can never visit? Skeptics call it metaphysics. Advocates say, not so fast. There may be shadows on our sky, fingerprints in the cosmic microwave background, clues buried in quantum experiments. Let's follow the trails. Section A. Inflation's fingerprints. Remember eternal inflation? If it happened, it left behind subtle imprints. Primordial gravitational waves, ripples in space-time, born from inflation's violence, should twist the polarization of the cosmic microwave background, the afterglow of the Big Bang. Instruments like BICEP, Lightbird, and the Simons Observatory are searching for these swirls. Bubble collisions. If our bubble ever grazed another, it might leave circular scars or temperature rings in the microwave sky. Some groups claim hints. Others say statistical flukes. The jury is very much out. Statistical tilt. Inflation predicts a specific spectrum of fluctuations, slightly more power on large scales than small. The Planck satellite measured exactly that, a quiet win. So inflation gives us handles. The multiverse rides on inflation's credibility. Section B, the cosmological constant puzzle. Then there's the cosmological constant, the vacuum energy that accelerates cosmic expansion. Theory predicts it should be gargantuan. Reality, it's tiny, yet not zero. This mismatch, 120 orders of magnitude, is the worst prediction in physics. Why so small? In the multiverse view, it's small because only in such universes can galaxies form, and only there can life arise to measure it. Steven Weinberg used this reasoning in 1987 to predict a non-zero but small constant. A decade later, dark energy was discovered. Coincidence? Or a clue? Section C, quantum foundations. On the quantum side, the many-worlds interpretation predicts no collapse, ever. So how to test it? If collapse were real, it should eventually show up as deviations in interference experiments, especially with larger and larger systems. From molecules to viruses, physicists keep scaling up. Still no collapse. And in practice, quantum computers are bets on many worlds. They run computations across vast superpositions that, in collapse models, shouldn't exist. Their success doesn't prove many worlds, but it does lean in its favor. Section D, distinguishing science from speculation. It's vital to keep categories straight. Some multiverse ideas, like level 1, infinite space, are almost inevitable given cosmology. Others, like level 2 inflationary bubbles, make testable indirect predictions. But some, like level 4, all math exists, live in a foggy borderland between physics and philosophy. They inspire thought, but risk leaving science behind if not tethered to data. Science must always ask, what would change my mind? Section E, the attitude of humility. The multiverse may never give us direct evidence, but gives us something else, perspective. It asks us to think bigger, to accept that our cosmos might not be unique. Yet humility cuts both ways. We must resist turning absence of evidence into evidence itself. We must design sharper instruments, cleaner experiments, better theories. The multiverse should not be a dumping ground for mysteries. It should be a hypothesis tested at the edges. So what would count? Indirect fingerprints, statistical oddities, patterns that make sense only if there are many universes. We may never glimpse another bubble, but we can glimpse their shadows. And yet, even if evidence grows, a deeper question lingers. What does it mean for us? If there are infinite versions of you, infinite choices branching, does that cheapen your life or make it more precious? Science asks, are there other universes? Philosophy asks, if there are, what does that mean for me? Because hidden beneath equations and telescopes lies the human question. If infinite versions of you exist, do your choices still matter? Section A, the multiplicity shock. In the many worlds picture, every quantum fork produces another branch. Somewhere, another you didn't pause this video. Another never discovered it. Another never existed at all. In eternal inflation, other universes may carry radically different constants. Some may be lifeless voids. Some may harbor life that looks nothing like us. And in a few, there may even be people who resemble us, but whose histories unfolded differently. That realization can feel exhilarating or devastating. Section B. Does multiplicity cheapen choice? If every possible outcome happens in some branch, does that make your decisions meaningless? If another you always takes the other path, then what weight does this used decision carry? Imagine a vast library where every possible book is written. Somewhere, your story is already on the shelf. Does that make the act of writing pointless? No, because you still live the writing. Being still flows in this moment. Likewise, you're not responsible for branches you'll never feel. You're responsible only for this live stream. Section C. Identity as pattern, not atoms. Philosophers like Derek Parfit argued, identity is not about the particular atoms that make you up, but about the pattern. If a pattern like you exists here, and another pattern like you exists elsewhere, are they the same person? The ship of Theseus asks, if you replace every plank of a ship, is it still the same ship? The multiverse raises this puzzle to a cosmic scale. The answer may be, each you is real but distinct. What gives your life meaning is not uniqueness, but continuity. The fact that you are the one experiencing this branch. Section D. Ethics in a multiverse. Here's a deeper sting. Does morality lose force in a multiverse? If in one branch you save a life, and in another you don't, does the heroism vanish? The answer must be no. For the people in this branch, your actions are everything. Pain is still pain. Kindness is still kindness. Reality doesn't dilute responsibility. If anything, the multiverse sharpens it. Out of infinite possibilities, this one exists, and you shape it by what you choose. Section E, the human response. Maybe the multiverse doesn't cheapen our lives at all. Maybe it dignifies them. Because even if there are infinite versions, no other branch has your exact story, your exact loves, your exact moment right now. What you feel, what you decide, what you give, that remains yours alone. The universe is not only stranger than we imagine, but stranger than we can imagine. And yet, within that strangeness, the meaning we make is still real. So yes, there may be countless yous, but there's only this you watching this video in this universe. And while philosophy wrestles with identity, science keeps asking another question. If the multiverse exists, could we detect it through unexpected pathways, like a cosmic simulation itself? That's next. The simulation hypothesis, a different kind of multiverse. What if reality is not just vast, but virtual? Not a multiverse of bubbles or quantum branches, but a multiverse of simulations. The idea sounds like science fiction, and yet some of the sharpest minds in science and philosophy take it seriously. Section A, the simulation hypothesis. In 2003, philosopher Nick Bostrom proposed a famous trilemma. 1. Civilizations like ours rarely reach the stage of advanced computing. 2. If they do, they rarely run large-scale ancestor simulations. 3. Or, if they do, then simulated realities vastly outnumber base reality. If 3 is true, odds are we're in 1. Think of video games. From Pong in the 1970s to photorealistic open worlds today, the leap is staggering. Project that curve forward 1,000 years. Imagine a civilization with computers the size of planets, or quantum devices simulating universes down to the atom. For them, simulating entire histories might be trivial. If it's possible, and it's cheap, why wouldn't they? Section B, simulated universes versus physical multiverse. This is not the multiverse of inflationary bubbles, not the many worlds of quantum mechanics. This is a computational multiverse, reality layered in code, each universe a simulation nested in another. Russian dolls, one inside the next, If we're in a simulation, then the laws of physics are not ultimate. there's software rules. And just as a game engine can run many worlds, a simulation engine could spawn countless universes. Section C, possible evidence. Can we test it? Maybe. Theory suggests we could look for signs of digital resolution in physics, like pixels in space-time. Maximum energy cutoffs. If reality is simulated, there might be a highest possible energy, like the max frame rate in a video game. Anisotropies. Tiny irregularities, like glitches, could show up in cosmic rays or neutrino patterns. Mathematical shortcuts. If the universe is a program, it uses compression tricks. Strange symmetries might be hints of coding. Section D, the existential unease. If we live in a simulation, what does that say about meaning? About free will? About purpose? Some argue it cheapens everything. We're puppets in someone's computer. Others say it changes nothing. Meaning is what we make, even if the stage is digital. A simulated love still feels like love. A simulated kindness is still kindness. Reality is that which, when you stop believing in it, doesn't go away. Even if coded, reality remains the only home we have. Section E, a different kind of multiverse. In the simulation view, the multiverse is not just bubbles of space or quantum branches. It's servers stacked upon servers, each spinning universes into being. And if simulations outnumber base reality, then our cosmos might be less real than we want to believe. But here's the paradox. If you're in a simulation, you cannot step outside to prove it. You can only look for faint glitches, clues left in the fabric of the code. So whether by inflation, quantum branching, or cosmic computation, the multiverse keeps returning as a possibility we can't quite dismiss. But if it exists, how could we ever falsify it? How could we ever know for sure? That's next. What could falsify the idea? Science lives and dies by one principle: falsifiability. If a claim cannot, even in principle, be proven wrong, it is not science, it is belief. So, can the multiverse be falsified? Section A, the risk of unfalsifiable ideas. The danger is clear. The multiverse can explain anything. Why are the constants this way? Because in other universes they're different. Why does life exist here? Because only here can it. That logic risks becoming a tautology, true by definition, but scientifically empty. A warning sign. If the multiverse is to remain in science, it must produce consequences, shadows we can actually test. Section B, inflationary multiverse tests. For eternal inflation, falsifiability comes through inflation itself. If future measurements of the cosmic microwave background sharply contradict inflation's predictions, say, no sign of the predicted tilt or evidence for a universe with radically different curvature, then the inflationary multiverse would crumble. Likewise, if gravitational wave experiments definitively rule out the energy scales inflation requires, the bubble universe model takes a direct hit. So inflation ties the multiverse to empirical risks. Section C, quantum many-worlds tests. For many worlds, the falsifiability lies in collapse. If we ever detect a real collapse mechanism, an actual physical process that kills superposition, then many worlds fails. That's why physicists push interference experiments to ever larger scales, from electrons to fullerenes to biological molecules. If a limit appears, collapse models gain ground. If not, many worlds becomes harder to dismiss. So here too, testable edges exist. Section D, the string landscape challenge. The string landscape is trickier. 10 to the power of 500 possible universes is not a prediction, it's a playground. To test it, physicists look for statistical evidence. Do our constants look like random draws from a vast landscape? Do unexplained fine-tunings disappear when embedded in the bigger picture? If one day we find a deeper symmetry that fixes the constants uniquely, then the landscape and its anthropic reasoning collapses. If not, it remains a contender. Section E, simulation hypothesis limits. And the simulation idea? That may be the hardest of all. If the code is perfect, no test can reveal it. But if glitches exist, energy cutoffs, anomalies in cosmic rays, strange discretization in space-time, they could betray the programmer's hand. If none are ever found, the hypothesis may fade. But absence of glitches doesn't prove we're real. It only leaves us with humility. Section F. Why falsifiability still matters. In all cases, falsifiability is not about final answers. It's about scientific posture. The multiverse may never be proven directly, but as long as it leads to specific risky predictions, whether in inflation, quantum foundations, or cosmological data, it belongs to science, not myth. Science must begin with myths and with the criticism of myths. The multiverse is today's myth under criticism. So yes, the multiverse can, in principle, be wounded, perhaps one day even killed, and that's what makes it science. But falsifiability still leaves a haunting echo. Whether or not we can prove it, the idea changes how we see ourselves. What does it mean to live in a reality that might be one among infinite? That brings us to our final chapter, where we go next. If this journey made you think, binge the Cosmic Mysteries playlist, hit subscribe, and share this with someone who loves impossible questions. Next episode, Dark Energy, the slow explosion tearing space apart.